Welcome everyone to the Trillium Flow Technologies A&M compressor discharge check valve. The A&M obviously stands for Atwood Morrill there. So today I'll be one of your speakers. My name is Steve Spack. I work here as Director of Sales for Trillium Valves USA. I've been in that position for the past 5 years. But I do have 35 years of experience in the valve industry, and I've been supporting Atwood and Morrill brand valves in various capacities over that time. I have a Bachelor of Science degree in Industrial Technology from the University of Massachusetts Lowell and an MBA from Salem State University. Also joining us today will be Jeff Hager. Jeff Hager is a product manager here, and Jeff has been serving as the product manager for the Atwood and Morrill valves for the past 4 years. Like myself, Jeff has numerous years of experience in the valve industry, and in particular in supporting the Atwood and Morrill valves in the engineering role over that time. Jeff has a Bachelor of Science degree in Mechanical Engineering from Union College and a Master of Science in Mechanical Engineering from Rensselaer Polytechnical Institute.
Good morning.
So before we get right into our presentation here, I'd like to introduce Trillium Flow Technologies. Trillium Flow Technologies is a manufacturer of highly engineered flow control products serving mission-critical applications. And Trillium provides support to these applications through the entire life of production to help maximize the efficiency and profitability of that equipment. Trillium has a global footprint of manufacturing plants and service operations centers. That service is provided across all the regions of the world, and Trillium prides itself on providing support throughout the life cycle of the valves. And as we'll discuss in some of the coming slides, that life cycle can be pretty extensive, as the Trillium brands are all designed to last the lifetime of the facility and really provide unparalleled service during that time. So when you look at the Trillium Flow Technologies brands, they have a very long heritage of innovation. You can see it starts out in the early 1800s. So pretty soon here, when you're looking at that, 1828 was the Blakeborough control valve line. So pretty soon that product line will be approaching its 200th anniversary. So that's a real testament to the longevity of the products and to the quality of them and what they provide in the marketplace. As you can see, even though we've been around for a long time, we really don't rest on those laurels. We work and are continually innovating in the marketplace to bring new products. And the one common thread that you get across all of these products within the Trillium portfolio is they're all highly engineered, high quality equipment. So in order to make it into the Trillium brand families, you really have to have a quality product that serves the process flow industry. So what we'll be talking about today will be the application of this valve, the features and benefits, and the product range and options. I'll take us through the application. Jeff will work on the features and benefits end, and then I'll wrap it back up with the product range and options. One thing to note is you're welcome to submit any questions that you have. You can send them in at any time, and if it makes sense to answer it during the presentation, we will do so. If it makes more sense to follow it up at the end, we'll do that. will also be hanging around at the end of this presentation to also answer some questions at that point. So we look forward to receiving questions on our products here and the application. So as far as the application goes for the Atwood and Morrill Compressor Discharge check valve, this valve is used in refineries, in the oil and gas and the petrochem marketplace. There's a number of different applications and systems that it can be used in. Some of these are listed on the left-hand side of the screen here: the fluid catalytic cracking, the propylene, ethylene, ammonia service, syngas, methanol, nitrogen. All of these services, this valve is used in. The one common thing that ties all of these services together is that they have a compressor in their system, and these valves are used to protect that compressor. So what we'll do here is we'll focus a little bit on fluid catalytic cracking, because this is really where this valve cut its teeth in the oil and gas and petrochem marketplace. So UOP, the developer of the first commercial fluid catalytic cracking process unit, actually lists Atwood and Morrill Compressor Discharge check valves in its specification. These valves are listed in that specification under special check valves, and the two applications that they call out are the regenerator inlet air special check valve and the main air blower discharge special check valve. So as you can see from both of these applications, the valve is really there to protect that main blower. So for the regenerator, the special check valve is installed on the discharge line from the main blower to prevent backflow of the catalyst from the regenerator to the main blower. And in the main blower discharge, its primary function there is to minimize the process gas volume for blower surge protection. So you can see that this valve is key to the protection of the compressor. And so we have a little diagram here that shows the system that this valve is located in. So on the right-hand side here, it shows the air blower and the compressor. That is usually driven by a motor, or you also have this with a steam turbine that can be located actually driving the air blower. And so basically the air will flow out of the blower compressor, flow through the check valve as it's shown here, and then it flows into the regenerator. So this air into the regenerator is basically introducing the air into that regenerator so that you can combust the catalyst in there. Basically, as the catalyst is cracking the feed fuel in the reactor, it actually gets a small coating of a residue on there and of coke. And so in that regenerator, you're looking to combust that off. So what happens is the reactor has that, does its job. You get the catalyst with the residue on it. It flows into the reactor. You introduce the air, you combust it, you burn off that coke, and now you've got the catalyst that is able to be used again. So then it will recycle back into the reactor, and this will keep occurring. So what the concern is if the air blower or compressor was to come offline for some reason, you would have a situation where you would lose pressure and forward flow in that air line to the regenerator. And so now all that catalyst that's in that regenerator is going to want to flow back towards the lower pressure end of the system. And it's going to try to make its way back to the blower and compressor. And if you ever seen any of this catalyst, it's a very fine powdery type material. So if it gets into the blower or the compressor, there's going to be a lot of work and downtime in getting that compressor back to an operating condition. So that covers the application. We're going to move into the features and benefits on the valve. So what we're going to talk about in this, and Jeff is going to take over with these items, but we're going to talk about the closure assist air cylinder, which is shown on the left-hand side here with number one little balloon there. We're going to go into the oil dash pot, which is the item on the right-hand side of the valve. With the two, we've got the counterweights on the valve that help counterbalance the disc weight. We'll talk about the protective sleeves, which are item 4 on this diagram. We'll discuss the importance of the lubricated stuffing boxes. And then we'll also talk a little bit about the disc and the self-aligning feature of that disc and how it provides a tight shutoff. And then also the bolted bonnet on our valve, which is a full bonnet, not just a view area. So you can actually maintain the valve completely in line. And then one of the other features we'll talk about is the unique incline seating of the valve, which provides us always with a positive closing moment on that valve. So Jeff, if you want to take it away from here.
Sure. Hello, everybody. Thanks for your time. Okay, the valve assembly feature benefits are listed on the left. The full access for the internals so that you can service it if you select to use a weld-end style valve. The low pressure drop, the wide flat seats that make maintaining the seats straightforward and also provide a longer leak path should you get a minor scratch. The rapid closure, the positive closing moment Steve just talked about. The counterweighted disc, which lets you reach full open earlier as the flow increases, which is due to that counterbalance disc. So on the disc assembly, it consists of the disc, which is the blue item, and the disc arm or hinge, that's the phantom green item. The self-aligning disc has some free play between the disc and disc arm to enable the disc to find the exact seat. So if as you're servicing it over time, if you lap it a little bit off the original surface, the disc will still find its seat and seal. When the disc is full open, the disc arm, the green part, has that little fin at the very top of it that contacts the body rather than the disc and maintains the integrity of the disc, and that if you get any deformation over many, many years, it's not on the disc, it's just on that disc arm stop. Positive prevention of the disc and arm separation. The disc is connected to the disc arm by trapping it with that nut and washer. The nut is then cross pinned and that pin is peened. So in order to separate these two parts, you actually have to take it out of the assembly to separate it, which gives that extra protection against dropping parts inside the valve. And the disc cannot spin or rotate due to those anti-rotation lugs on the backside of the disc that entrap the disc arm. If the disc was to spin, you could have higher wear and also wear the disc post to the point where it was weakened. So these features make the valve very robust and extend its life in the plant. So this is showing the disc and arm assembly with the shaft. The shaft is a one-piece shaft to avoid any problems that some of the industry has experienced with the two-piece shafts. And then hardened shaft bushings provide, again, long service wear over time. Here's the power assist cylinder. The parts are detailed on the left. I'll point out the piston rod has a spherical nut and lock nut at the top. This is what engages with the lever arm, which has a fork. The fork straddles the piston rod, and this spherical nut contacts it when it's going in the down direction, but it's not connected. So that enables you to pressurize the air cylinder the piston rod will move up out of the way, permitting the valve to free swing, but it will not force the disc into the open position. We'll talk more about that in a minute. And this enables you to, the air cylinder enables you to have a rapid response to reverse flow condition and ensures that the disc is moved all the way to the body seat when the flow is stopped. So here the air cylinder is shown in the de-energized conditions, so that spring approaches its relaxed condition, pushing the piston down, pulling the piston rod down, and the spherical nut pulls down on that lever arm fork you can see in the picture. The lower switch will be tripped if there's no forward flow. If you still have forward flow, the spring is not sized to close against forward flow. Its intent is to be a number of times stronger than the expected packing friction after the packing is in the open, is exposed to the flow conditions over a long period of time. It breaks that packing friction and encourages the disc to the seat as the flow decreases. Next slide. So this is shown with the air cylinder pressurized, which compresses the spring, moving the piston and the piston rod up. The extended piston rod enables the valve to free swing to the open position when sufficient flow is present. And so that upper switch will be tripped when the flow drives the disc to the open position. If your flow is only sufficient to move the disc off the seat, but not fully open, the lower switch will untrip and the upper switch will not be tripped yet. So you'll have a indication that it's somewhere in between. And we have a solution we'll talk about in a little bit if you want to know really exactly where the disc is. So here's a picture of the fabricated version of this valve. Up to about 48 inches, we'll typically use a cast body. Once you get over that, the body transitions into this fabricated version. It can be provided as flanged or weld-in version, but it still maintains the bolted bonnet, full access to the internals, and all the other features and benefits that we've talked about. The disc in this particular case is stopped by a fabricated stop that's to the right of the cover area, and it will contact the disc post when the valve is in the full open position. And there's also a cross-section view of the shaft showing the disc arm and bushings and packing and protective sleeves on the shaft. Here's the oil dash pot. So the piston rod, the dash pot piston rod has a bellows that protects the interface to the guide in the cover from dirt and debris. The piston itself does not have any seals, so as you open and close the valve, oil flows around a small clearance between the cylinder and the piston, and the piston, as it moves back and forth, will pump the oil through this loop. So there's a needle valve in the first loop where you can adjust your dampening, and there's a relief valve in the second loop that provides protection against if you have the damping adjusted way down and you get a sudden slam as the piston tries to pump the oil through that needle valve. If the needle valve isn't open enough for the speed with which you're closing, that relief valve will open and let the oil go through so that your valve will still go quickly to the seat. And there's a cap and a vent to accommodate with temperature changes. And in the case of overfilling, it will enable you to eject some of that oil if you've overfilled it. On the right-hand side, you see the piston rod is directly connected to that fork, unlike the air cylinder side, which is not connected. And this provides damping through the whole stroke. And the mounting bracket and pivot pin enable the dash pot to rotate a couple degrees either direction. So as that lever arm strokes open and closed, it actually follows a circular path so that you need a degree of freedom there for the dash pot to stay aligned with the fork. Next. So here's a few of the protective sleeves on the shaft, the air cylinder, and the dash pot. The shaft bellows has a band clamp on the right-hand side that tightens it down over a metal sleeve that rides on the stem. So as the valve rotates, that bellows doesn't twist. The motion actually occurs on that little sleeve. And then on the air cylinder and the dash pot, they're actually clamped to the piston rods. And so they'll extend and retract as the valve opens and closes. This bellows is provided as a rubberized fabric. So it is subject to decay over time. So it's a good idea to keep an eye on them, and as the rubberized fabric becomes brittle, replace them so you don't lose your protection against debris. Here's a view of the lubricated stuffing box. The lantern gland on the left is in the center of two packing sets, and the injector goes through a hole in the body that you permanently mount this injector to the valve. And as you inject the packing grease through, it goes through this little ball valve and spring to inject it into the stuffing box. That ball valve enables you to pressurize the valve, and the pressure does not get past that ball into where the injector bolt is. You also can see on the right, there's a packing gland that compresses the packing, live loaded springs that enable you to maintain the packing load over time as the packing wears, and then the bellows, which provides that protection against debris.
Okay, so we've gone through the features and benefits. So what we'll do here is we'll talk about the product range and options, and then we'll review on the features and benefits to close up this presentation. So sizes, the typical sizes that you find these valves in are 8-inch through 72-inch, but we can go larger than the 72-inch. That's the typical size range that you would see these valves in. One thing to note is on the lower end, so below an 8-inch valve, we really don't call that out, although we do have a design for that. Some of the concern gets around when you get into the smaller sizes is the weight of the disc. So the disc in that valve, you always want the default of this valve to be the one to close. So the concern gets as you get lighter disc in there, and because you have to have the shaft penetrate on both sides of the valve, one side for the air cylinder and the other side for the oil dash pot, you have a lot of packing friction in there. And the concern with the 6-inch and smaller sizes is that packing friction will actually could cause that valve not to close. The disc won't have enough weight to overcome that packing friction. So there's a concern that the response time will be slow on that. So what we'll do in cases if a 6-inch valve is required, we look at taking the dash pot off if that's a viable option. On the 8-inch and the 10-inch valves, we even look at using a O-ring stuffing box instead of a conventional packing arrangement. But the limitation there is on the temperature of that. You can't really get above 350 or 400 degrees on the O-ring materials. So since a lot of these are subjected to a high temperature, that becomes difficult. So when you're talking in the 10-inch and under range, it's really something that we have to take a look at and know a little bit about the process as far as the temperatures that you're going to see and the concerns, and then we can look at that and see what we can put together as an optimized design to address those. In the pressure classes of these valves, they're typically in the 150 and 300 range. Reason for that is you do have some temperature in it, but on the flip side, the pressures that you're dealing with aren't that extremely high that it pushes you up into those higher pressure classes. Now, having said that, there are some processes that this valve goes in, and one that comes to mind right away is the ammonia process that we have it in, that we do require a higher pressure class. That one actually requires a 1,500-pound valve. And we can certainly do that. One of the things that we pride ourselves on here at Atwood Morrill, and I think across the Trillium product lines, is our ability to provide customized solutions for your process needs. So if you've got a requirement that kind of falls outside of the normal product range of a lot of companies' valves, we can typically manufacture a valve that will meet that. We'll, use our similar designs, but we'll modify them. And really, when you look at it, that's how this valve was kind of born in the first place. Is it started out as an extraction steam check valve, preventing steam flow back to a steam turbine. And when this application came up, it just seemed like a natural fit. And we just had to add some special design features to it to make it suitable for the different process. So when we talk about the end connections, we can do butt weld end connections, which are perfectly fine on these valves because you do have full access to the internals, as Jeff mentioned earlier, through the cover. So there's no need to remove it from line if you want to maintain the valve. It can be completely refurbished in line. However, if you want a flanged end valve, we can absolutely do that. And typically on these valves, I'd say it's probably about a 50-50 split between butt weld end and flange ones that are required. So on 24-inch and under, we use the B16 5 flange requirements. And then on anything above 24-inch, we look at B16 47. And typically we go with the Series A design on that. But we can do the Series B if it's needed. We just kind of need to know that up front because we'll have to do some modification to the pattern equipment for these valves. And, it'll probably add in a little extra cost there, but we can definitely accommodate it. As far as materials go, because we're dealing with the lower pressures and the temperatures, even though they're elevated, they usually stay below that 800 degrees. So most of the applications are WCB. We do have some cases where, because to design for maybe upset conditions that the system may see, we will provide a WC6 or a WC9 body material. And on other occasions, we've supplied stainless steel material to deal with some, especially like we've seen some units that have had oxygen service has been introduced into it or higher oxygen levels. So they want to have a stainless steel valve. We can also do these in a low alloy carbon. We can do it LCB when we get into the low temperature valves. The normal seat on these valves are stainless steel. That seating surface has been used since the beginning with this valve, and we're going back 60, 70 years plus on this valve. Those seating surfaces hold up very well under the operating conditions that you would see in these units. And because they're a wide flat seat, and the impact stresses are taken up by those, they tend to last a long time. So the stainless steel seats are perfectly fine for this. However, if you have an application that you would prefer to use hard face number 21 seating surfaces, we can absolutely do that. It's just a little bit more cost-wise for that, but it is something that we can do. But really, when you look at it, the stainless steel seats should handle any of the services that you have. We also do have a test valve for the air cylinder piping. This test valve is in there to allow you to test that air cylinder. So the real function of that is to make sure that air cylinder is ready to work and perform its function on this valve, and also to make sure that the valve is in operating condition. So basically, when you trip that either a hand test valve or a solenoid test valve, it will equalize the air pressure on either side of the cylinder. The spring force will take over, and it will start to move that piston rod into the retracted direction. That will contact with the lever arm, as you can see on the right-hand picture here, and it will start to pull that lever arm down. And what you're looking for when you exercise that is just the piston rod to move a little bit and see that the shaft is free to rotate. That's all you need to see, because once you see those two things, you know this valve is in good working order and it's ready to respond to a reverse flow if you have one. So in that case, you just, with the hand test valve, you would just release it. The solenoid valve, you take your finger off of the button, use to control it, and everything goes back to normal, and the valve operates as it normally would. Important to note that you cannot close this valve off against forward flow with this air cylinder. It does not have enough spring power in there to close off against the forward flow. Its real function is to just provide assurance that disc is going to close. It's to break any kind of packing friction, which Jeff had mentioned earlier, from the valve being in the open condition. Break that packing friction, get that disc closing and down into the flow stream, so that when you do have reverse flow, the reaction is instantaneous there. We also supply the solenoid valve on the piping system. That solenoid valve is the main dump valve for that air cylinder, and basically it would receive a trip signal that the compressor has come offline, whether that's through a DCS system or some kind of other control system, to the valve. We also provide the air filter regulator to make sure that the air that's going into that air cylinder is clean and dry and at the right pressure. The air filter regulator, and keeping that air in good working order for the cylinder, is key to making sure that you minimize the repair work that you're having to do on that air cylinder. We also do offer position indication. We can do that through various means. Even without position indication on this valve, you can tell whether it's opened or closed just by the position of the lever arm and the counterweights on the disc there. That lever arm would be pointing in the more vertical direction, while the lever arm will have moved more and the counterweight more into that more horizontal position, and that would show you it as full open. But if you want any kind of signal back to a control room or anything like that, we do offer a position transmitter on this. We typically offer the TopWorks unit, which is nice about the TopWorks unit is it does have a built-in junction box to it, so you can kind of get an all-in-one type of an arrangement on there. It's also got an integral proximity switches that we can use in there. But if you'd prefer to just have a mechanical or proximity limit switches, we can certainly do that. We can mount them in the open and closed positions. You can even put one in like an intermediate position, a test position if you wanted. Those were shown in the earlier slides in the arrangement. And if you need a separate junction box, we can always go ahead and put on another junction box for the valve. So those are the main options that you have with this valve. We'll just wrap up here by reviewing the advantages of our valve design, and then we'll stick around and take any kind of questions that you may have on the valve. So one of the key advantages to our valve is it's a proven swing disc design. The swing disc design has been around, I think, for as long as valves have been around out there. So it's a very simple design, very reliable. And reliable is the key word here, because when we get into the closure assist air cylinder on this valve, that's providing additional reliability. So you're taking a valve that's inherently reliable and you're adding on that closure assist that's giving you a little extra reliability to make sure that valve is going to start to close, breaking any kind of packing friction. So you get the idea. It's all about reliability to make sure that this valve is going to close when you absolutely need it to protect your expensive piece of equipment and prevent downtime that's going to cost a lot of money in getting the unit back up and running. We have the wide flat seats that we've been talking about. Very good for giving you a tight shutoff. They're a very forgiving seat because it takes a long path for a leak path to start through one of these as opposed to a line contact seat. And as opposed to a tilting disc valve, which could possibly become wedged in the seats, this valve cannot be wedged. So that's where you get the non-jamming feature out of it. You've got the dash pot to dampen the disc oscillation and prevent slamming. So with a pulsating flow going through the valve, you're going to have that tendency of the valve disc to ride that flow and kind of have wide swings in there. So with that dash pot, you're able to dampen out those swings. You're able to adjust it with the needle valve that's in the piping system. So once you get this valve up and operating, you can really dampen that swing out so that you get a nice steady performance out of that disc. We've got the protective sleeves and lubricated stuffing boxes to prevent damage and ingress of foreign material into this valve. You really want to keep that bearing area free from any kind of contaminants, because it's critical, again, that the valve is able to close, so you don't want anything gumming up that area and slowing down your response time. We've talked about the inline maintenance through the top cover. Rugged construction. So this is something that's common to all the A&M products and quite frankly, all of the Trillium flow technology brands that are out there. These products are built to last. They're really designed to last the lifetime of the facility. And there's no reason, if you take care of these valves and maintain them properly in accordance with the instruction manuals, that these valves won't last as long as the plant's going to last. The other thing about this valve is the 30-degree seat, which gives you the rapid response to a reverse flow, so you get a quick closing time on it, but it also enhances the low pressure drop. So you have the counterbalance, the 30-degree seat. You've got basically an eighth of a turn because you're traveling through 45 degrees to get the valve into the full open position where you can pass the maximum amount of flow. So the pressure drop is extremely low in these check valves. And the other thing is kind of tying in with that rugged construction and the seat angle, is that this valve is designed to withstand repeat rapid closures. So if you get a reversal of flow, that closure is going to be extremely fast in the valve, which you want it to be. But this valve is designed in such a way that it is going to hold up to that reversal of flow and provide you with long life. So that kind of wraps up the valve itself. these valves are designed, and the principal location of manufacturing is in our Ipswitch, USA facility, which is up in the northeast corner of the United States up here. Along with the design, we have full machining, welding, and assembly and pressure testing capabilities. But when we talked earlier about the global footprint of Trillium Flow Technologies, it's important to note that this valve can be manufactured in any of our locations in a worldwide basis. So if you need some local content, you probably more importantly, if you do have this installed in another location, chances are there's a factory that's regionally located that's going to be able to help you out with this valve. So that's something that really, I think, sets us apart from a lot of the manufacturers out there. So that wraps up our presentation here on the Atwood Morrill Compressor Discharge check valve. We would certainly be happy to take any questions that you may have about this valve, or questions about valves in general. We'll try to help out there. It's always, we can play stump Jeff Hager on this with your valve questions.
Thank you. Thank you, Steve. We also like to mention that in addition to designing and manufacturing these valves, we also service it. So we have a service network throughout the world that will enable us to come in and service the valve for you, train your people to service the valve properly, or provide supervision for your service crew to maintain these valves. The maintenance, the weekly testing or monthly testing of the air cylinder through that hand test valve is very important to keep the valves operationally ready, and the regular maintenance is also important. So please do contact us when you're in a position to plan your maintenance for future outages.
So we do have one question on the presentation, if it's possible to share it. One thing to note is that shortly after today's presentation, this presentation will be moved up into the Trillium Flow Technologies YouTube channel, and it will be available from there. But probably more importantly and specific to this question, if there's anything specific that you would like out of the presentation, you can certainly contact us at the address above, and we would be happy to do this presentation for any of your teams. If you would like to have other people introduced to it, Jeff and I are always willing to do that. So just let us know, and we can share what we have. So one of the questions too is, do we have any a list of AMLs that these valves are on currently? So as I had mentioned, UOP, we appear on their specification for our valves. So if you look at their special check valve specification that comes with their process, will be listed on there. There'll be our name and address and everything, and then it will say it'll give a drawing number, which is a typical drawing for this valve. So we are on that. I know we're on a KBR process, but we can basically get you a list of approvals that we have for this valve. A lot of times, because this is a special valve, it doesn't a lot of times end up in the normal approval process that some of the bigger oil companies might have out there, but we can certainly share what we have. So I know that question will work on getting you a response to that and sending that to you directly. And then I think one of the questions that we have, okay, we'll certainly do that. I'll contact you. We got information from, is it Shah? We will definitely get in contact with you. So one other thing while we're waiting to see if there are any additional questions that might pop up, Jeff had mentioned about the service for these valves. It's also important to note on some of the older valves that you may have out in the field, on some of these older refineries. We do fully support the valve, no matter how old it is. We have a very good track record of, or not track record of records on these valves. So even if it's a really old valve, might have been out there for 50, 60 years, there's a good possibility that we can track it down to its original order and provide any kind of replacement parts that you want to refurbish that valve. We've even taken some of these valves back into our shop. Sometimes over the years, they start losing pieces off of them because someone's done some work on it and removed something, and they've taken off a lever arm, and then you find the air cylinder has disappeared and the oil cylinder. We can actually refurbish the valve back to its original state with all the accessories on it. Okay, it looks like we might have run through all the questions that people may have. Oh, wait a second, got one quick one coming in here, so maybe we haven't. Yeah, so the question goes around, what is the recommended spare parts for maintaining the valve? Are they in the soft kit form? Jeff, do you want to take a crack at that one?
Sure. Depending on the age and how often you have serviced the valve, there may be a base spare part kit, and then we can add to that as you need. Typically, packing in gaskets, anytime you open the valve, you're going to need that. Bearings and shafts, if it's got quite a few years on it, those probably will be needed. And then the bellows, over time, will, depending on what environment they're exposed to, they're going to tend to get brittle and will need to be replaced. On the air cylinder, there is a standard air cylinder repair kit with the replacement seals that need to be replaced periodically. And then over time, if your system is less than clean and you've been slamming the valve violently, you may want to entertain refurbishing the seats and replacing the disc. But those are typically the parts that we'll see over time. And they can customize a spare parts quote to meet your needs, depending on the age of the valve and how polite you've been to our valve.
So interestingly enough, to shamelessly plug our YouTube channel, Jeff and I had done a presentation earlier, a webinar earlier this year that is up on the YouTube channel on check valve maintenance. It doesn't specifically address compressor checks, but it does address extraction steam non-return valves, which are close relative to this valve. It has the same basic design of the valve. It just doesn't have some of those extra accessories like the oil dash pot and the protective sleeves and stuff like that. But it gives you a good idea on how to maintain these valves and what the intervals are to do that. Okay, so I think we've run through all the questions. You're certainly welcome to send anything in. If you do think of a question after this, you can contact us at the email address over here on the left-hand side of the presentation, and that will find its way to either myself or Jeff, and would be happy to answer any questions that you may have. And also, again, if you'd like to have us do an individual presentation for your team, we would be happy to do that. So thank you very much for joining us today.
Thank you for your time, everybody. Have a good day.